Hello everyone, in this video we are going to learn about routing among the internet service providers, the inter-domain routing protocol that is commonly used called BGP, Border Gateway Protocol. BGP is maybe one of the most important protocols in the internet. Obviously we have IP, which is the glue between the lower and upper layers in the TCP/IP stack, but BGP is necessary for sending information from a particular point in the world to another destination in the world. So it's a kind of glue that interconnects the internet and that holds the internet together. BGP is thought to be used in terms of sessions. We have two possibilities. The first one is a session called exterior BGP. So eBGP, the idea is to know the reachability of destination networks, destination ASIS autonomous systems, and provide this information to other domains, let's say. Once we know information about distant networks, distant domains, we can propagate this information inside our domain. So in this case, we are going to use interior BGP sessions to say the rest of the nodes in the domain, which is the reachability of a particular destination. So here is very important the concept of policy, because each network administrator on each domain has the opportunity to establish policies in terms of routing in an exterior way. For example, I don't want to give my routing information to other domains, or I don't want to use this network to go from my network to a destination network. I'm trying to bypass this specific domain. So there are some policies that are set by the network admins in terms of inter-domain routing. So the main goal with this protocol, BGP, is to know the existence of the rest of the internet. So each network has to advise, I'm here. This is the information I have from the rest of the internet, in order to have the whole information in terms of reachability available to the rest of the networks. This is an example of BGP connections separated in exterior and interior BGP connections. So we have three domains, three ASIS, Autonomous System 1 in blue, AS2 in red, and AS3 in green. They are different domains. Maybe they have different interior routing protocols, or IGP, interior gateway protocols 1 for AS1, IGP2 for AS2, IGP3 for AS3. So maybe they have different interior gateway protocols, or maybe they are the same. Okay, so the interior routing can be, for example, OSPF for one of them, RIP for the other, and so on and so forth. And we have border nodes, 1C for AS1, AS2 has two border nodes, 2A to connect to AS1, 2C to connect to AS3, and finally AS3 must have a gateway router to be able to exit to the internet. So eBGP, exterior BGP, is the connection between border nodes, for example, 1C with 2A and 2C with 3A. Imagine that 1C, which is a border node in the first AS, receives information about the reachability of this autonomous system, number 3. Then it is able to propagate this information to the rest of the nodes in the domain, saying, okay, I have this information, now you have it. Then if another autonomous system, for example, number 4, is connected to AS1 and this uh, gateway router is able to propagate information it knows up to the moment by means of eBGP session. So this is the process for propagating the information about reachability in the internet by means of BGP. Here we have another example in which 3 autonomous systems are connected by means of these links. These links are used in a semi-permanent TCP connections. The idea is to use port 179 for the connection between border nodes, 1C with 2A, 2C with 3A. Now, imagine that we want to propagate the reachability information from X to the internet. So in this case, 3A will send the information to C in terms that you can reach node X or destination network X by means of autonomous system 3. 2C, which is the border node of AS2, is able to propagate this information to the rest of the nodes in the domain, also reaching to A, which is another gateway node that will be able to use this information for propagating the advertisement. So 2A will send a message, a BGP message, in a eBGP session, exterior BGP, because they are communicating in different other systems, saying that you can reach destination X, which is connected to autonomous system 3, but you have to first pass through me because I am AS2. So this path is sent from 2A to 1C. AS3X is another path vector that is sent from 3A to 2C. Once 1C has this information, it is able to broadcast the info to the rest of the nodes in the domain, and so on and so forth. So with this information, for example, 3A, this one, promises to the autonomous system number 2 that it will forward datagrams towards X, which is the semantic of this kind of messages. So BGP works with attributes. We have prefix blocks, attributes to set the route. For example, in the previous case, we said that we can reach X from AS3. The 2 important attributes are AS path. In this case, AS path is AS3. This is the destination. It is not taken into account in terms of attributes, but there is another important attribute called next hop. If we go back, the next hop that is advertised by 3A to 2C to go to X by means of AS3, this is the next hop, the interface connecting 2C with 3A. So So the next hop indicates the specific internal AES router to next hop AES. So the next hop, the next interface to reach the next AES. So BGP works with policy-based routing. So each network admin is able to define its own routing policies in terms of interdomain routing. For example, I would like to never route through, for example, one specific AES called Y, and I'm also able, if I'm the network admin, to decide if I want to share a path or an advertisement with specific networks or not. For example, imagine that I have 3 adjacent AESs and I would like to only share the information with one of them because I don't trust in the rest. In this example, we want to advertise that X is reachable. How to do it? So the border node 3A will send a message, an advertisement with this information. Destination X, AES path AES3, and the next hop is this one. Once 2C has received this information, 2C is able to share this information with the rest of the node by using BGP. 2A is able to propagate this information using eBGP with 1C, but it has to add a new AES to the AES path. In this case, the destination is X, the first AES is AES3, and the second is AES2. Then 1C is able to propagate this info to the rest of the nodes in the domain. Let's see now another example. Imagine there is an additional link connecting AES1 with AES3 directly, okay? So in this case, once we receive the reachability information knowing where X is, 1C receives 2 possible paths. The first path is going from AES1 to X by means of the direct link, then reaching AES3, and then finally reaching X. The other opportunity is going through AES2, then AES3, and finally X. In the first case, which is this one, going directly, there is only one AES that I have to pass through from AES1 to AES3. In the other case, case number 2, there are 2 S's that are in the middle. So AES1 decides which is the policy. In case of having multiple choices, I have to decide. For example, one policy could be use the shortest path in terms of autonomous systems. So in this case, I will select this policy. And that information is also expressed inside the network. I previously said that eBGP messages are exchanged between peers over TCP connections on port 179, but which are the kind of messages we can play with? The first one is open, to open such connection, to connect both entities. Another message is called update with normal advertisements. I want to reach destination X, and this is the AES path, this is the next hop, this is the normal message. Another different message is keep alive. Keep alive is used to say, okay, I'm alive, there are no updates, but I'm continuously working, so you have to take me into account, and a fourth message is notification to report errors in previous messages. Or for example, if I receive a BGP message with an AS path in which I'm also involved, uh, it will require to create a loop. So it is not possible. I would like to avoid loops, so I will discard it and notify by means of the notification message. Now we are going to learn which is the content of a particular forwarding table, routing table when working with BGP. Let's focus again on the same example. We want to reach X, and imagine that this is the border node that receives this information, this advertisement. So in this case, we want to know which is the content of node 1D routing table. In order to reach X, I have to go through first my gateway node, which is 1C, and I will have to use this outgoing port. So the destination is X, the final destination, and the interface is port 1, because I'm going to go to the next hop by means of outgoing interface number 1. Another example. Now we want to fill the routing table of 1A. In this case, this is the gateway node as well, and I would like to decide which is the next hop to go toward 1C. I have two possibilities, 1 and 2, using this path or using this other path. For example, I decide in terms of interior gateway protocol that the next hop is 1D, so the interface is number 2 to reach destination X. Next, we are going to learn the hot potato routing. With the same destination in mind, X, I'm focusing on this autonomous system, number 2. This autonomous system runs on a specific IGP protocol, interior gateway protocol, for example, let's see, OSPF. And we have a cost on each link. For example, we want to know how to exit the domain on node 2D. The hot potato routing establishes that we want to exit the domain as soon as possible using the shortest path without considering exterior BGP policies. So now we have two possibilities to exit the domain. The first one is to exit by means of 2C, or the second one is to exit passing through 2A. Which one to select, 2A or 2C? We have to select the one with the least cost path. In this case, we are going to select this opportunity, this option, because we have a cost of 201. Instead, if we want to exit by means of 2C, we have two options. The direct link cost is 263, and if we go from 2D to 2B to 2C, we have a cost of 264, which is bigger than this cost, so we exit through this node in order to reach the destination. In this case, we don't take into account the policies in terms of number of ASs, just we want to exit from the domain as fast as possible, like a hot potato that it is on our hands. So we want to exit the AS2, and we will use the least cost path to exit the domain. Well, In case of receiving two advertisements to reach the same destination, which one to select? We have a list of priority actions. Let's say the first one is to use the policies that are defined in the domain by the network admin. If there are no specific domain policies, the first option is to select the path with the shortest AES path, the shortest number of AESs to be traversed to the destination. For example, in the previous examples, we have two possibilities: going to X by passing through AES3, which is only one AES autonomous system, and the second option is to reach X, which is connected to AES3, but we have to pass through AES2. In this second case, we have two AESs. So if we have to decide, we will select this option. In case we have the same number of AESs to go to the destination, we have to select the closest next hop router. I mean, we have to apply the hot potato routing explained in the previous slide. If there is also a draw, we have to select additional criteria. But normally, with the second and third steps, it is enough to select a particular path. Now we are going to see an example to understand how the policies are established in a BGP architecture. In this case, we have three provider networks, A, B, and C, and three customer networks, W, X, and Y. So in this case, A sends an advertisement to B saying that B can reach W by means of A. Additionally, B sends a message saying that to X saying that it can reach W passing through A, passing through B. So since X is a client or customer network of two different provider networks like B and C, I give you a question. Do you think that it is interesting for B to advertise the same path to this other network? The answer is no, because B and C are provider networks, so B doesn't need to use its resources to advertise a competitor network. So if C wants to know how to reach W, it is A that must advertise C that it can reach W passing through A. So B and C are both provider networks. They are competitors, so they don't give the other information about itself. They don't want to share resources to benefit the competitor. Finally, we are going to see the differences between intra-domain and inter-domain routing. First of all, we are going to focus on policies. In the inter-domain routing, the network admin wants to control the traffic, and it is able to establish some policies according to its preferences. For example, I don't want to use this AES that is a neighbor to route the traffic, or I want to bypass it. In the case of intra-domain, since there is a single network, there is no need for establishing policies. In terms of scalability, the hierarchical routing, like the one we have learned in OSPF, saves table size, which is a constraint in the routing processes, because the memories on the TCAMs are limited in size. So we have to use traffic engineering solutions to reduce the number of rows to be installed, the number of rules to be installed in the flow tables. And finally, the performance. It's important in intra-domain routing because we can play with the cost, we can reduce the delay, the congestion on the links by playing with the weights in the links, the costs. And in the inter-domain routing, it's more important to establish good policies that satisfy the network admin instead of focusing on the performance. It's more important to avoid passing through a specific domain, for example, a country we don't trust in, instead of reducing the delay or improve the network performance.